So let's talk about the question that everybody must be asking. Where's friction? Because all of the questions that we've done so far, the problem explicitly states that the surface is frictionless. Well, now it's not the case. Now we're introducing friction. So, friction is a resistive force between two objects in contact, and it's parallel to the contact surface and resists motion. Pretty intuitive, if you're watching these videos, you should have a basic understanding of what friction is already. The symbol is typically capital F subscript lowercase f, or just lowercase f, and the units are going to be in newtons, just as all forces are. And here we have an equation. So we have the absolute value of the friction force is less than or equal to mu times the normal force. So mu is little squiggly u thing is the coefficient of friction, and it measures how grippy two surfaces are. So this will usually be given to you in a problem, or you're going to have to figure it out. And it's typically 0 point something. You'll see it when you see a friction problem. And then normal force is just the normal force between surfaces. We already gone over this in the forces video. And then moving on, we have two types of friction. So kinetic friction and static friction. Starting with kinetic friction, it's the friction between objects that are moving relative to each other. So that sounds a bit complicated, but if the objects are already moving, then there's a kinetic friction force. And here's the equation right here. The direction of it opposes motion no matter what is happening. So you can see that in the free body diagram. We have a free body diagram video somewhere. I'll explain a little bit more about kinetic friction in a moment after we learn what static friction is. So static friction is the friction between objects that are at rest relative to each other. So they aren't moving. And you're going to be like, wait, if they're not moving, then how do you produce friction? But think about it this way. When you're pushing an object, initially, before that object begins moving, you're going to have to put a little bit more force into it to break the static friction. And then after it begins moving, then that friction switches to kinetic friction. And then static friction is basically always greater than kinetic friction. So after you get the object moving, then it becomes easier to push on the object because the friction opposing you has turned into kinetic friction and therefore is lesser and won't oppose your applied force as much. The thing about this is the magnitude of static friction will adjust itself to be whatever is necessary to keep the object at rest relative to each other. Let's say that this box requires 700 newtons of force in order to break the static friction. Then if you apply 699 newtons to it, then it's still not going to move. And if you apply 1 newton to it, it's not going to move either. But if you apply over 700 newtons of force onto it, you're going to break the static friction force and get that object moving. And we will be doing a friction problem, hopefully. So stay tuned for that.